Jim McDivitt, you've flown before in Gemini 4 with astronaut Ed White. Would you tell us just a bit about your flying career and what you've been doing since Gemini 4? First of all, when did you start flying at all? You were in the Air Force.
Well, my first flight was in an airplane was after I got into the Air Force, and it was back in 1951. Since then, I guess I've had not a normal Air Force career. It was pretty normal up till about 1959 or so, and then I went through the experimental test pilot school out at Edwards Air Force Base and been acting as a test pilot ever since then.
So you were one of the second group of astronauts to be assigned to NASA, and most of you came from the test pilot ranks, as I recall.
That's correct. That's correct. There are a number of Air Force and Navy test pilots in our program, and I think in that second group, I think they all were.
Mm-hmm.
There's some civilian test pilots, too. I shouldn't slight them, and also Marines. I want to make sure we give fair credit to everyone.
What impresses you most when you back way off and think about this flight and Apollo 9? What's the single thought that hangs with you most closely, other than doing a good job?
Well, that's the single thought. Now you want one besides the single thought.
I'm assuming that, since I know you're conscientious.
Well, it's really hard to say. I think that the doing the good job is really utmost in my mind. I think that to get people to work the kind of hours that we all work, and I don't mean just the pilots, I mean the people that support me either directly on my flight crew support team, or the people that work for the good of our mission in the flight control division, and all those people in the engineering development division within NASA, the contractors and everything, to work the way they do means that they all really feel that the goal of getting to the moon is a worthwhile thing. And I'm just pretty happy to be playing my little part in getting us there. Of course, we're not there, and I hesitate to see everybody feel that it's going to be automatic because we've had a couple successes. I think we still have a long ways to go, and I hope that our flight contributes something to the knowledge of the ease or difficulty of getting there.
Jim, what is it like to have to learn to fly two spacecraft for one mission? You're going to be piloting both a lunar module and a command and service module on Apollo 9.
Well, I used to think that it would be 2 times as hard as flying one vehicle, but I found out that it's a lot more than 2 times as hard. It's like 10 times harder. It just seems that the 2 vehicles are so complex that you learn one, and then you start on the other one, and by the time you've really gone through it, you've sort of forgotten the things you learned in the first one, and it's a never-ending circle to just stay up to date with all the systems of the 2 vehicles. And then when we discuss the operations, we fly in so many different configurations. Command and service module only, command module only, command and service module dock with the lunar module ascent and descent stages together, lunar module ascent stage only, command and service module dock with the ascent stage only, all of this on the S4B. We have so many combinations that it's really a spectrum of flight that we're going through, certainly flight vehicles that we're going through.
You've amplified the observation that came from Apollo program manager General Sam Phillips a few weeks ago, in which he said Apollo 9 is a much more complex mission than the previous Apollo manned flights. I'm sure you must agree with that then.
Well, I don't think it's fair to compare one mission with another mission.
Well, you have the extra spacecraft, of course.
Well, that's true. I think that each mission has its own little niche to fill. It's a little sort of a cog in a big wheel that's going to roll us onto the moon. It's certainly the most complex mission I've flown, and I can say that because I can compare one to another. I think each mission has its own milestone, and we have ours, and we're going to try to take care of it.
You and Dave Scott and Rusty Schweikert have joked with us about the complexity of the mission and the intricate training you've gone through and the many things you still have to learn. How do you really feel about it at this point in time?
Well, there's an awful lot before each mission, and I think that we're going to have to get it all done, and I think that everybody knows that they're not going to launch us until we're prepared. When we go, we'll be ready. We're never going to be as ready as we'd like to be. You know, you could train for a mission forever and never really be satisfied that you knew every intricate detail, but I don't think it's necessary to know the minutest detail. We have a wonderful team on the ground that can fill in the details.
That's what I was coming to next, is you do have extensive support from the Mission Control Center and from all over the Earth where you'll be orbiting.
That's right. We have a number of NASA flight controllers in the Mission Control Center, and they're supported by the contractors who have designed and built our equipment. And if we need to know something about it in flight, we're certainly going to get the best advice that we can possibly get.
Jim, I believe that the most crucial and one of the most interesting aspects of your flight will be that rendezvous day when you and Rusty Schweikert will be in the LEM, the lunar module, separating away from the ship which can get you back to Earth. That, number one, is important, isn't it?
Yes, and by the way, that ship will get us back to Earth. Not can, but will get us back to Earth.
Okay. Tell me what you'll be doing there during the early separation parts of this maneuver, this all-day maneuver.
Okay. Early, we check out the spacecraft. We do this while we're docked to the other vehicle. But there's only a limit to what we can do. So we'll undock, fly around the command module while he observes the different parts of our spacecraft from his spacecraft. And then we'll separate only out to 3 or 4 miles to make sure that everything is operating properly. If it's not, we'll be able to come right back in. If all is going well, we'll configure the spacecraft to do what we call a phasing maneuver, where we will fire the descent propulsion system. We will have checked out the radar. In the beginning, we will check out the alignment of our inertial platform by looking at stars through a telescope. When we've confirmed that these things are okay, we'll go ahead and make this maneuver, which we call phasing. It'll be done on our descent propulsion system. We'll actually use our abort guidance system, which is a backup computer and flight control system to guide during this particular time to evaluate that system. After we lit the engine up, we'll start out in a very large circle that's sort of shaped like a football, and we'll be referring to these things during the flight as footballs. The little maneuver we make is what we call the mini football, and the larger one, where we'll go out to about 50 miles, we call the maxi football.
I assure you, my associates and I are spending a lot of time explaining that.
We're really not playing football, we're playing rendezvous. As we go out, we'll evaluate the spacecraft again. Now at a longer range, we'll be able to look at our radar and how it performs at long ranges. If it's going well and the rest of the spacecraft is performing as it should, we'll come down to the bottom of our football and receive a go from the ground to continue our separation out to 100 miles. As we pass back close to the command module, probably 3 or 4 miles away, we'll be tracking him with our radar. He'll be observing us to see that everything's okay. Then we'll come up to the top of our football and light our engine again. This maneuver is called the insertion maneuver, and once again we'll be using the descent propulsion system, but throttled down to its minimum throttle so that it's more easily controlled and can put us in a precise orbit.
Mm-hmm. Speaking of this throttleable engine, say that word for me.
Throttleable.
We're all going to have a lot of trouble with that, too.
That's right. Well, fortunately, there aren't very many throttleable rocket engines. There are very few, and we have one of them.
The second part of the rendezvous exercise is concerned with maneuvers which bring you back to the command module, in which Dave Scott is watching you all along. Would you summarize what you're doing at that time, Jim?
Certainly. We've gone through some earlier maneuvers that have put us on a trajectory that causes us to increase our range from the command module, and we'll go out to a range of approximately 100 miles. As we're doing this, we'll go through 3 distinct maneuvers which will cause us to return to the command module. They have letters CSI, CDH, and TPI. The significance of the letters really doesn't amount to much, except that
they're engineering terms.
They're engineering terms, that's right. What they really mean is that the first maneuver will cause us to come to an orbit which will be shaped exactly like our target vehicle, the command module, but will cause us to be about 10 miles below and flying along at the same constant altitude difference of about 10 miles. When we get down to the bottom where we are 10 miles, we'll fire the engine again so that we'll stay at the 10 miles. And then as we come in, we'll do another maneuver called TPI, which will cause us to come up from the bottom, change our 10-mile altitude to 0, and we'll come up in a sort of a fishhook-shaped maneuver, which will bring us from behind and below to a point that's slightly in front and equal altitude with them and close to a range of 25 or so feet before we start our docking maneuver. Mm-hmm. One of the interesting things with this particular rendezvous is that our target vehicle, the command module, is really more than just a target vehicle. It's a dynamic vehicle, and although we don't normally plan on him doing anything, he's always prepared to make the maneuver if we can't. So the one man in the command module is responsible for operating that whole vehicle, calculating all the maneuvers that we do, and prepared and has to be prepared to back up our maneuver. So if we find out that one of our engines won't work, he can fire his engine a minute after we should have fired ours, and we stay in the same relative position. So this particular relative motion that we have always remains constant, regardless of whether the LEM has a problem or not.
Are you getting as much information from the ground, from mission control, as is the command module during this period?
Well, actually, we receive the same information because we have a very difficult time of coordinating communications between the lunar module, the command module, and the ground. We worked out a procedure where the ground sends information to the lunar module. The command module copies it down, and we copy it down, and then by applying some constant biases of a minute, a few feet per second, he can work out the maneuver that he should do, and then he does that one if we can't do our own.
Is all of this does all of this go into your computers?
Yes, indeed. The command module has one computer, and the lunar module has two computers. We have radar that we can use the radar information with some charts, so that we can actually figure out the rendezvous with a set of charts and some paper and pencil. However, it's not nearly as convenient as using the computers, and we much prefer the computers.